In class today we started with 4 functions. We want to find the intercepts and graph these 4 functions. Okay, the x-intercepts are found by letting y equals 0, and of course our functions are all of the form y equals. In other words, we're going to let y equal the value of the function. So y equals 0 when? Okay, well, the zeros for this function are very easily found. The value of the function is going to be 0 if any of these factors is 0. So if the factor x minus 3 is 0, that gives us a 0 when x equals 3. To make this factor 0, x is negative 1. This factor is 0 when x is negative 4. And we plot those points. I haven't labeled them. This is supposed to be negative 4, 0, negative 1, 0, and 3, 0. And they're not spaced exactly proportional. It looks like 3 and 4 are about the same size, but we're not going to worry about that. Okay, so we easily find the zeros, and we plot them when we find them. And those zeros are all intercepts. They're the x-intercepts. And then the y-intercept, x equals 0 is what gives you the y-intercept. So if x is 0, you have negative 1 times 4, which is negative 12, giving us the point 0, negative 12. And everybody did pretty well with that. And once we got everybody on line on the page with this, people easily found the intercepts for the other 2 functions. And the intercepts for the second function are spaced like this. They're at negative 6, negative 2, 2, and 5. And the y-intercept is 0, 1, 20. And here the y-intercept is 0, 9. And the x-intercept is negative 1. Then the task was to sketch a smooth curve. And we had to work a little bit on that, getting the idea of what a smooth curve was. But you know, some people wanted to go straight from here to here and then straight down here and straight up here. That's not the way this function behaves. It forms a smooth curve, and the only way to get from here to here with a smooth curve is to either go above the axis or below the axis. If we went below the axis, then we'd be above the axis and wouldn't be able to get below it again until we got here, because the x-intercepts are the only places the graph can cut the x-axis. So we can't go down this way and back up, because if we did, we wouldn't have any way to get down to this 0 here. It's also important to understand that the points have to be connected in order from left to right, or if you prefer from right to left. You can't go here, then here, then here, and then back to here, because that would have the function turning around on itself. It would have 2 values for certain x values. You'd have 2 values for the function. It wouldn't work. Okay, so we're pretty much stuck with a graph that looks like this. We discussed in terms of this function what happens if x is bigger. Okay, and if x is large compared to the values at the x-intercepts, compared to the zeros of the function. And the intercepts are at, the largest one is 4 units from the origin. I just chose x equals 10. 10 is somewhat bigger, at least twice as big as any of the intercepts. So it has twice the magnitude of any of the intercepts, meaning the point where x equals 10 and then the point where x equals negative 10, which we also want to look at, is considerably further from the origin than any of the zeros. So that's how the x equals 10 was chosen. The question is, what and where is the point when x equals 10? Now we can plug in here. We can plug in 10. This term would be 10 minus 3 or 7. This would be 10 plus 1, 11. This would be 10 plus 4, which is 14. Okay? Now 7 times 11 is 77, and then you multiply that by 14 and you get a pretty big number, okay, close to 1,000. So the answer to the question, if x equals 0, what and where is the point? Well, the point is 10, whatever this multiplies out to, and I'm not going to do that in my head. I'm not going to take the time. But it's something like 10, something close to 1,000, which means it's way, way up there. So that when the graph goes through here and down to here and up to here, it doesn't just stop and tail off somewhere. It really takes off in the vertical direction. Similarly, if x is negative 10, you can check it out yourself. You're going to get negative 13, negative 9, and negative 6. They're all negative. It's going to give you a negative result. And it's going to be a pretty big number, much bigger than any of the numbers you see here. It's going to be way down here. And if x gets bigger, if x is 100, well, all these numbers are going to be close to 100, which means the product of three of them is going to be close to 1,000,000. Negative 100, negative 1,000,000. So this graph really takes off here, really takes off here. Now, this graph behaves very similarly. Actually, I want to digress. Okay, we do have these points here, and it would be possible for a graph to do something like this, where it's 0 just for this instant. It never goes past 0, much like the vertex of a parabola on the x-axis. So it would be possible for the graph to do this sort of thing, but it's not possible for the graph of this function, which consists of three linear factors. There's a reason for that. By linear factors, I mean just like x minus 3, not x minus 3 squared or cubed, and same with x plus 1, x plus 4. First power, not a second or third or fourth or whatever power. Okay, so this kind of behavior can occur, but will not occur for this f of x function. Okay, the g of x function then is pretty straightforward. We plug in x equals 0, we get the y-intercept at 0, 120. The x-intercepts are at negative 6, negative 2, 2, and 5. So I'll just write negative 6, negative 2, 2, 5. If x is a large positive number, say x is 10 or 100, doesn't matter. As long as x is bigger than any of these zeros, all these numbers are going to be positive, and we're going to be multiplying them together, which is going to give us a really big positive number. If x is a negative number, bigger than any of these zeros in magnitude, then all these factors are going to be negative. If x was equal to even negative 10, which isn't all that much bigger than the negative 6, we would still have negative 11, negative 8, negative 4, and, I'm sorry, x was negative 10, negative 5, negative 8, yeah, I'm sorry, now, if x was negative 10, we'd have negative 15, negative 12, 8, and 4, okay? We'd have two I don't think I said it right even now. Negative 15, negative 12, negative 8, and negative 4. I'm not sure I said the negative on the 4. In any case, all four of these numbers would be negative. If x is bigger in magnitude than any of these numbers here, then all these numbers are going to have the same sign. There are four of them. This means that on the left, thing goes way up. On the right, it goes way up. Positive, and it gets big. So that the graph will go through the points in this manner. Okay, now, this last function, y equals h of x equals x minus 3 quantity squared times x plus 1. I'm going to do this on a separate clip because there are a couple things we need to think about here.